morning students, this is Rajkumar Yadav and today I am going to tell you another topic, how to solve the homogeneous differential equations, right? It is from 9.5 the NCERT book, right? Chapter 9 is going on. So guys, I have taken the question number 1 here. The question number 1, what is that? X square plus xy into dy is equals to x square plus y square into dx. It has been given there and we have to find out the solution, right? So first of all, we have to separate them, like dy by dx is there. Obviously, this equation, differential equation, is not separable. Like we did in the last videos, that if the differential equation is separable, then we do on another method. We take that dy and y function one side and dx and x function of x on other sides. Here it is not possible. So we are going to learn how to solve this type of situation. Right. First of all, you have to prove that whether it is a homogeneous differential equation or not. It is very simple. You have to see that the degrees, degree of this one is, every term degrees must be same. That is the requirement. So there is a 2, the degree of y square, that is 2. That is 2. Again, how we check the degrees? That 1 plus 1. In variable, the degree in the product form, the degree will be adding up. The 1 plus 1, that is 2. So every term has a degree 2. This is the short way to find whether it is a homogeneous or not. But how to write? If he asks that how to write or how to prove this is a homogeneous equation, then what should we do? That you should take it as fxy, right? X square plus y square upon x square plus xy. Now replace this x by lambda x and y by lambda y. So then what happens there? Lambda x, lambda y, lambda x and lambda x into lambda y. I have replaced everywhere x and y as lambda x and lambda y respectively, right? So you can see there, if you can see that it means it is now, if we solve that, what happens there? Lambda square will be common, so that it will become like that, and here also lambda square is common, so it is like that. You see that lambda to the power 0 here, right? And it is already, we know that it was fxy from this equation 1. You can see like that. And it is f lambda x lambda y. Means if there is lambda to the power 0, if you got the lambda to the power 0 here and fxy means the same, only the difference is lambda to the power 0 is there, means 1. So that will set to be a homogeneous differential equation. It is the way to find how we can prove this homogeneous, right? The first thing is done. Now we have to solve it. How we solve it? Let's see. You have to pause your video and then write it properly. Then now once we decided that this is a homogeneous equation, then what is the next? The next step is you have to put y equals to vx there and differentiate this, right? What is that? dy by dx is equals to v into differentiation of x, that is product rule. I am using the product rule here, that is 1 and x dv by dx, right? So guys, you have to now change this equation, that v plus x dv by dx means in place of dy by dx you have to put that, and also here we have already taken that vx means vx whole square. It can be equation number 2 in this video, according to this video, because first one taken earlier, right? Again x square plus x into vx, right? You can take x square as common, 1 plus v square is there, also x square is common, 1 plus v is there. cancel out. So what happens that you have to take the LCM. So we got dv by dx is equals to 1 plus b, right? 1 plus b square minus b square. I have taken only the LCM. It will go there and this cross multiplication. You know that b square will be cancelled out. 1 minus b. You can see there. That is 1 plus b here, dv by dx into x. Now I am separating them like we did earlier in the last exercise. 1 plus dv will go there and 1 minus b will be there, and here dx, right, and upon x. Now it is the simple question. Now you have to integrate that. How we do that integration? That is 1 upon 1 minus v is there, right, and the v upon 1 minus v. You can write like that, right? And if you need this minus sign there, because you know all the methods of integration, I think so. Minus must be multiplied there, so that we got the minus sign. Then add 1 and subtract 1, right? Again dx upon x is there. I am solving that. It is obviously log 1. This one will be 1 upon x type of formula, that must be log x. So we will do that later on. But 1 minus b upon 1 minus b into dv plus 1 upon 1 minus b into dv is equals to 1 upon x dx. First of all, you have to check that whether it is correct or not, right? You got this 1 plus b, right? Now you have to integrate that. It will be cancelled out. This will be 1, right? Now guys, it is the same thing. So it will be 2 upon 1 minus b dv, right? And this is 1 into dv. Now integrate all the things. Now you can integrate all the things, right? What is that? If you can see there, you can pause your video and write it properly. That is log 1 minus b upon minus 1. The integration of that, and then minus b is equals to log x plus c. C must be anything. Here, if you write here only c, the answer will not match, if you can see. So you have to take anything so that it will be log a, right? It is log a. I have taken a different constant so that we can match the answer. If it is not required to matching the answer, you can take anything, right? But if it is given to prove that, find out the particular answer, then you have to match for that, right? So it will be log a into x. I have taken this. Now what is that? We can do that here. Minus b is there, and take this in that direction, that is plus 2 log 1 minus b. Can you know that this will go there? So it will be log 1 minus b whole square, and now so we can take that 2 there, log 1 minus b to the power 2 plus log ax. You can take that log 1 minus b square into ax. Now we can put the values, right? We can put the values. If you are seeing that, minus y is equals to, that y is equals to vx. So what is to put there? V is equals to y upon x. Again you can see there we have taken that one. So that is y upon x log 1 minus, it is in the product form, y upon x whole square into ax right now. So if you can remove this log from here, it will be removed like that. This is the formula or basics of log, you know that. And this one is 1 minus y upon x whole square, that is x square upon, you can take this as a LCM into ax. That's why x minus y whole square upon x square into ax, and this will be like that. You can, if you can see that here we got this one. Again, x will go there and upon a will be there, minus y upon x minus y whole square, right? And now 1 upon a can be taken as c only to match the answer, that is cx. You can leave here also, but if it is required to prove the answer properly, then you have to do all these things. Otherwise it was only to integrate them and put the value again into form of y and x in place of v. Otherwise, but we have to find out the answer properly, then we have done this. So guys, you can see that this is the answer. Now all the best. Thank you.